everybody that's joined to our 5th episode of Detection Dispatch. If this is your first time joining, we're really happy to have you guys here. We give a few minutes for everybody to trickle in, so we're just going to kick it off now. My name is Jeanette. I'm here with from marketing at Anvilogic, joined by Kevin Zuck, who's one of our forward deployed engineers here at Anvilogic as well. And he's going to be delivering an awesome session on all things PowerShell. But before I kick it off and hand it off to Kevin, since if this is your first time joining, Detection Engineering Dispatch is a series that we created for detection engineers. It's a place that we can come and level up our skills together. It's a place that we can come and learn from like-minded experts. And we have a variety of sessions that we host. If you've never attended one of our sessions, you can always visit anvilogic.com/workshop to see our previous sessions. We had an awesome capture the flag experience last time. We're going to have more like that going forward. But anyway, welcome to everybody here. About to kick it off. If you have any questions during the session, please feel free to drop them in the chat or come off of mute if you'd like to. But you can also DM me directly here on Zoom and we'll get your question up to Kevin. Otherwise, I'm going to pass it off to Kevin and let him take it away.
Okay. Hi, everyone. I'm Kevin, obviously. What you're going to want to do is go to this link and follow along. There's going to be examples in there that you can analyze using your browser with the tools I'm going to show you. So here's where you'll find PowerShell scripts in an analytical context. The first is process logs in Windows. It's not enabled by default, but if you turn it on, you also have to turn on another flag to get command line parameters. And that's what's primarily going to collect the PowerShell scripts, arguments to PowerShell.exe. So that's one way to do it. Again, not enabled by default. It has an overhead associated with it. But that's one way. Another, and probably the most common, is EDR software like CrowdStrike, SentinelOne, stuff like that, Carbon Black as well. That type of stuff will use like a proprietary engine and drivers to collect these PowerShell scripts that you can then analyze. A lesser used option is Sysmon, just because of the overhead required. It takes a lot of setup and it's kind of noisy as well. So a lot of overhead. You can also enable what's called script block logging, which is basically everything the PowerShell engine sees, it will tell you about. And if there's an obfuscated script, it will show you like every single step just because of the way PowerShell works. And if you collect files off of disk, it can be in a .ps1 file as a PowerShell script. It can be in a batch file as, you know, just arguments to PowerShell.exe. So those are the typical places you'll find them. And the most common cases are usually malware delivery and shellcode execution. For malware delivery, there's a lot of different types of downloaders ranging in complexity. And shellcode, you know, once you get there, you're talking Cobalt Strike, Metasploit, that type of stuff. So you'll commonly see shellcode as well. And we'll go over what that looks like and how to, you know, analyze it. So here's some things you'll find in PowerShell scripts, or things that should give you pause and make you think that they're malicious. They often involve obfuscation. The more complicated the piece of code, the more likely it is to be obfuscated. So if there's encoded data in there somewhere, like, for example, encoded commands and encoded script or shellcode, you're going to be dealing with an obfuscated script for sure, just because of the size and complexity of that stuff. So they often involve encoded data buffers. That's what I said before. It may contain C2 servers, so you're always going to want to be looking out for C2. And I'll show you what that looks like in a script in a bunch of different ways when we get to the examples. If a script involves basically just preparing and putting stuff in memory without with API calls, it's probably malicious, just because that low level of code is very beneficial to a malware author. But, you know, most legitimate stuff is higher level and they don't have to actually manipulate memory directly. But for malware, it's beneficial. And it's beneficial to use it with PowerShell as well, just because the engine has a really close connection with Windows. If a script needs to be decoded more than once, it's probably malicious, just because you might make an argument that something could be encoded once just because of, control characters or, OS specific stuff in there. But after one layer of encryption or encoding or compression, if there's multiple after that, chances are it's malicious. Some of this stuff could set off your AV, but it shouldn't. It doesn't set off mine. But be careful. If you're on a Windows machine, you might not want to write these to disk. It might set off an AV alert. So try to keep it in your browser. So we're going to start with static analysis, which is basically looking at the code and not executing it, but going as far as we can to figure out what it does and how it works. It's the first step of script analysis. As soon as you're looking at the script, you're basically doing static analysis in your head. It can show you everything code is capable of if you truly study it, if you study every branch it can go to, which is nice. When you run a script or piece of malware dynamically, like you run it on a sandbox, it's going to show you the path that the code took. It's not going to show you the paths that it didn't take. So if you have a backdoor that can keylog, but the keylog capability was never activated, or it needs to be activated manually, and you run it in a sandbox, you're never going to see the keylog stuff, but you might if you statically analyze it. It works best. The smaller the sample, the better static analysis works, because the larger it gets, the more moving parts and the more you have to do guesswork. Dynamic analysis is when you run a script. Works very well with obfuscation, because if something's obfuscated, it still needs to run in the context of the operating system. So basically, if you run an obfuscated sample, you're doing a lot of the analytical work automatically. You'll see what it does like automatically. But like, again, you won't see everything it can do, just what it did when it ran in the sandbox. Works well with analyzing huge amount of samples, because you can just, all malware is designed to run. Otherwise, it wouldn't, there's no point for it. So it's a good way to analyze a bunch of samples. They should all run. So it requires a safe analysis environment. You have to set it up internally at your company or pay somebody to do it through your browser. One downside to it is if there's any like anti-sandbox or anti-VM and you run it in a sandbox or a VM, you're not going to get the full story, because it'll stop once it detects that stuff. All right. So the first tool we're going to use is CyberChef. It's a static analysis tool, great for PowerShell and really everything. I use it multiple times a day just through log review and stuff like that, things that I need to decode and look at. You can write scripts in Python to do it for you, although that's starting to become less common. Now that there's tools like CyberChef where you can like show your work to somebody else and stuff, but not unheard of. You can use disassemblers, but that's going to require a high level of knowledge of the operating system and stuff like that, and specialized skill set. You can use utilities to run shell code and emulators, which is useful if you have a little piece of shell code. Shell code is just code that's meant to run kind of like in line for something. So it's not a PE file. It's just a section of code that is passed. Once control is passed to it, it does something bad. Sandboxing, I'll show you a little bit of that. And a disassembler with a debugger is a way to both look at the code statically and step through it, although that takes a lot of time and skills to do. So we're going to be using CyberChef. Allows you to decode, decrypt, decompress data, and do a bunch of other stuff. It's standalone, so I'm going to give you a URL that you can go and get it. If you want, you can just download it to your local system and it'll run and not reach out to anyone. But the code that's hosted here is not going to be receiving information about what you're doing. It's just going to serve you up the JavaScript essentially. There's nothing wrong with going here. It's designed to work on Windows, but obviously when you're analyzing Windows malware, the ideal OS is non-Windows. So we generally use CyberChef to try to figure out as much as the script does that we can by hand. But if there's shellcode and stuff, we won't be able to do all of it. So a couple things here. Since we're going to be using a sandbox, You have to be careful to not upload stuff that's specific to your organization. So if, let's say you have an active attacker that's trying to compromise you, you upload the sample, if they're paying attention, they can see that, and researchers can too. So be really careful about what you upload. Don't actually execute any of this stuff, just use a sandbox. This will only work in Windows, obviously, because it's PowerShell and it's closely linked to Windows. There's a chance that AV may trigger alerts, but it shouldn't. Try not to save stuff to disk. Okay, so let's get to the good stuff now. Here's some stuff you might see in logs day to day that you might be wondering about. This inline code here is just writing hello world. It's encoded here. Let's go to our first example here. What I'm going to do is chuck this into CyberChef. If I can just move this thing here. Okay. Let's go to the first example here. Very simple. This is something that's perfect to statically analyze because there's no obfuscation at all. But if you don't know what everything does here, basically you're going to have to use Google to figure out exactly what everything is if you don't get it. IEX, really common to see. It's basically invoke expression. It means whatever is passed to it, executed as code. And it's weird to constantly be using that normally, because like the script itself should be able to run, you know, as a PS1 or batch file. So if you see it more than once in the same script, that's odd. In this case, all this does is it uses this new object.net web client and then .download string. This is the name of the method. In order to figure out what this stuff actually does, I recommend looking at Microsoft documentation. So all I did to get here was basically like, I started throwing in things from the script. So if I wanted to put in this, if you don't know what something is, you're gonna have to throw it into Google basically. And the second result here, Microsoft, let's go there. Now, this is documentation by the people that are in charge of PowerShell of what this does. So if it's documented on Microsoft, it's good. Not everything is documented though, but most of it is, especially involving PowerShell. So what you see on the left here is all the methods for system.net.web client here, and download string is the name of the method. So all I did was, well, I guess if I started here, I can look on the left here, click methods, and then download string. That's how I got there. Okay, so what does this actually do according to them? It takes one parameter, which is address, and that is defined as a string containing the URI to download. Okay, so what this is going to do is go here, download whatever it is as a string, and pass it to IEX. So what that effectively does is download and execute PowerShell from here. So that's just a common example you would see, very simple, and not obfuscated at all. Let's get a little more complicated here. Another way to do something similar, but it has more arguments. Now we have system.net.web client still, but now instead of download string, we have download file. So we have to go back here. Let's go back to the Microsoft documentation here. We're still in, are we in web client? Yes, we are. System.net.web client.download file. So that should be in here, download file. So this one's a little more complicated. It takes two parameters, unlike the first one. The first parameter is address. So that's very similar to download string, but there's also a second argument, file name. So this downloads from the address and saves it to file name. So a little different. And notice in this case, a couple things. We're downloading an executable directly, which depending on your organization, that may or may not work. Like the more mature your organization is, the less likely you're going to just be able to go out to, I changed the URL. It was remote before, but I changed it to be safe. But going out to the internet, downloading an executable should be blocked at your proxies. But sometimes it can get through, especially if, you know, the machine's not in front of the proxy or something like that. But it downloads an executable, and then it saves it to the second parameter. So it's going to take the environment. It's going to take your app data environment variable, which is like a place in the OS for you that's app data. And it's going to be saved as the same name. And instead of an IEX, what we have next is start process. So let's go back to Google. Oops. Let's go back to Google and see if we can get anything on this. Okay, so more documentation. So this one can take a lot of optional flags and stuff like that, but we don't have all of them. We just have a real simple one. So instead of IEX, which only executes PowerShell, we're going to start the process of the executable we just wrote to disk. So this is an executable and run downloader. This can be any piece of malware. This could be ransomware if they wanted to, but typically it isn't, because they have to figure out how your environment works first and deploy it to as many machines as possible. Usually this would be some kind of first stage backdoor that then somebody might come through and do bad stuff with. Now we're getting into obfuscation. So we have a little bit of case changing. And the reason somebody would do the case change like this is if you wrote a rule, even for like Anvilogic, if you wrote a rule that said, I want case sensitive, anytime system.net.web client shows up, I want to know about it. But you make it so it's case sensitive, this will get past that. So be careful like that. There's also a lot more going on here. We have a fake user agent here. We know it's fake because the real user agent is PowerShell. We know that because this is a PowerShell script. So we know this is fake, which already makes this suspicious because it's adding Mozilla. We're not on Mozilla. We're not even using a browser. So this is all just copied from somewhere else. That's strange. And if you were to request this through the proxy and you're recording user agent, it will show the fake user agent because that's what has been made the header here. We have, this is also proxy aware through this nasty little thing here. System.net.web request default web proxy. It's just going to use the one you already have configured. So if you ran this one before and you're set up to go through a corporate proxy, it'll just fail. It just won't go anywhere. There won't be any route. Well, if this was actually an internet destination, which it was, it won't work because this isn't proxyware. It doesn't inherit your proxy settings. This one does. So I'd be a little more worried if I saw this too, because this means that if they're doing this, it basically means they're going after corporate users, because people at home, regular users that they would have run malware, don't have a proxy setup at home. So that's strange. We have a key here and also another download string, which we know about before. I've changed the URL again for it to be safe. But it downloads a .asp script, which we know is also fake because it's a PowerShell script. And here is our first encryption. We have a -b XOR. I know this is going to be kind of hard. If you don't look at this stuff regularly, it's going to be kind of hard to tell what is what. Part of that you can break up through this thing here. If you see that, you can safely do an enter. There's also code beautifiers out there that might make this look a little bit nicer. But since we've analyzed these two already, we know that it adds a user agent and it inherits your creds. We know it has a key. Here's another new line or another command broken up. Oops, let me just chuck this in somewhere since it's getting hard to look at here. Okay, so this is just a key. I = 0 is usually used in a crypto loop to start. I mean, in this case, it's used I = 0 is just for the crypto loop. And we have the download string, which we know about, and then we have this. So what's important here is this b XOR. Okay, so that's here. This is literally how I do my job every day. If I don't know something, I just chuck it into Google and then remember, what I saw. And then over time, it builds your knowledge. But okay, so this is a bitwise XOR, which without going into a huge spiel here, what that is going to do is it's going to take this file here and it's going to decode it, but byte by byte with a key that's shown here. So it's going to take the first character of this and it's going to XOR it with this, and then it's going to go to the next character. And then once it gets to the end, it's going to rotate back. So what this does altogether is it is a downloader that has a fake user agent, is proxy aware, contains an embedded key, and binary XORs the result of whatever it downloads here with the key. So if you had like a PCAP or something and you saw them go here and get this ASP file, which isn't a real ASP file, you would be able to use this key in CyberChef to see exactly what they downloaded, which is nice. But if you don't have PCAP, which a lot of places don't, you can still use this sometimes. For example, if there was a file written to disk that was XORed and you also had the key from the logs, that would be another way to do it. So that's all I wanted to show for that. Okay, so now we're going to get into all the annoying stuff that makes this hard to do or harder to do. These are the common ones you're going to see. If you're just a security analyst looking at logs and alerts and stuff from EDR or Windows or Sysmon or any of the places I mentioned, this is the stuff you're really going to want to watch out for. So Cobalt and Metasploit uses gunzip to decompress and compress shellcode. We'll get to that later. I'll show you an example of that. Inflate and deflate is another reversible compression method. A lot of downloaders will use inflate in combination with some code that it wants to compress to make the command smaller and harder to analyze. They'll use that. For shellcode, you would be able to hex dump it and use a shellcode loader or an emulator to see what it does, but we're not going to go over that for this. This is a little bit that's a little bit advanced for this. I'm going to show you a command called magic, which if you're totally stuck and you don't know what an encoded thing is, but you think it's encoded, you can always use magic to take a guess for you. I'll show how that works. You can use code beautifiers, and all that will do is basically it might uncapitalize all the stuff here, and it might make it look closer to this than what it started as, and make it closer to that than what it started as. Base 64, very common, probably one of the most common encoding methods. Encoding means it's reversible just by knowing the method and if you have a key. A lot of the time when you're looking at this stuff, you won't have a key because it'll just be ASCII hex or base 64. But if you know something's base 64, you can unbase 64 it, which is nice. Any questions? Okay, let's go to this guy here. By the way, if you haven't gone here yet, in case you want to try them yourself, CyberChef's here, obviously. I showed you the URL before, but I'll leave it on screen for a couple seconds, just in case you want to go there. This code's safe to run. Okay, so now we're on 4. This is the start of a PowerShell script, or it is a PowerShell script. Now, if you see this, it just looks fundamentally different than the other ones I've shown you. And it's important to note that there is a giant elephant in the room to me just by looking at this. It's the giant buffer of data here. What is this? We need to figure that out. We know it's PowerShell. This has to be PowerShell because it's passed to IEX. And I told you before, invoke expression only works for PowerShell. And it's also gzip encoded. So there's a couple layers here. I mentioned layers before. If there's layers Usually no bueno. So let's start with this. I'm gonna just go through. Actually, I'm gonna start with the whole thing and get rid of stuff that I don't care particularly too much about. This checks for the bitness of the OS, I believe, but I'm not positive. It doesn't really matter that much. If all you get from it is a number, chances are it's not extremely important. What's more important in security analysis is strings. So this not particularly interesting. It just, what this tells me here is the person that wrote this script doesn't know if they're going to be running on 32 or 64-bit. And based on whether it is 32 or 64-bit, it will look here. So I don't care about any of that. Let's just delete it because we've looked at it. And I want to focus you on the stuff that matters. System diagnostics, process and start info. I mean, we could look this up in Microsoft documentation, but since it has no arguments yet, I'm not super interested. And we have here, I don't know exactly what this does, but it's not super interesting. Now, here's the juicy stuff to me, at least. We have hidden. So this is gonna, when this runs, it's not gonna show a PowerShell window, which is used in a lot of malware, because if the user goes to runs a suspicious file, and then nothing happens after, but they see their PowerShell window open for a second when this runs, they might get spooked and report it. So the person that wrote this does not want them to do that. They don't even want them to know that this is happening. Now, this is totally different style of code here we have. Now we're using new object IO memory stream. And if you remember from before in the presentation, I said that if a piece of code is largely meant to prepare and manipulate memory over and over again and do a bunch of encoding and decoding and all that, it's probably malicious. I could look this up in Microsoft documentation, but no arguments, so I don't care too much yet. That leaves this from base 64 string. So let's look this up real quick. Let's go to here. Oh, throw this into Google. Okay, convert the specified string, which encodes binary data as base 64 digits, to an equivalent 8-bit unsigned integer array. Okay, only takes one argument, and it's string, the string to convert. So you can duplicate that functionality, this from base 64 string, with CyberChef directly, just by using it like this. Okay, so I'm going to take the string from the script, the whole thing, go back here, go to there, get this, and chuck it into CyberChef. Okay, so this is what it looks like encoded. All we're going to do is we don't want to use to because it's already base 64 encoded. We want to use from. And all I do is drag it onto here, the recipe part here. Okay, well, unfortunately, this looks like junk. So let's keep going, but this is a disappointing result. So we've basically done this part already. Next, we have IEX, but what it's going to use for gzip stream is, well, I've destroyed part of the script. So let's go back and look at it here. Take this. So S is this. It's this whole giant thing here. So it's the thing we tried to decode and it didn't work. But remember, the result of this is passed to IEX, and it takes the result, reads it, read to end. We can look that up if we wanted to in Microsoft documentation, but it's going to read what's there. But the interesting part here is it says gzip stream. So we're going to have to do more work here. But let's say we didn't know. Let's try to use magic here. It works. So all I did to do this, I dragged magic here, and it showed me the most likely result of what this is. The lowest entropy is most likely what it is if it did it correctly. And you can see what the result is clicking here. And what we have here is another script. And we're going to have to analyze that. But first, let's go back, put magic back. Use this. You could even use this like to start with. So if all you had was this, which would be really weird because you have to get it from a script, but let's just say you only had that. Let's see what it does. It may or may not work. It might need the base 64 part first. Nope. So see, it actually did find it without me even knowing anything. So this is a very useful tool if you have a piece of data that's encoded and you don't know what it is. So it figured it out without even me choosing base 64. And I can just click there to get the result. So that's all good. And when I clicked the result, all it did was add gun zip to the end of it. So base 64 is it, and then gun zips it. And that's what it said here. So we can get rid of this, or we can keep going. It's going to start it as a process, as a hidden window. Create no window equals true. Redirect standard output equals true. I don't know exactly what this does. You could look it up in Microsoft documentation, but we've analyzed the first layer, and the analysis, the big picture of the analysis is that there's another layer we need to analyze. So let's go back and get the other layer. It's this, chucking this in here now. Okay, so same deal. Now the theme is a little different. The theme of the last layer was I have a script embedded here. I want you to decompress it and then do something with it. But now there's more stuff that really gives me pause here. First is the randomly named functions and variable arguments. That's strange. There's no reason to do that. But there are builders for malicious scripts that will do this stuff for you, make it obfuscated for you. Now, when you're dealing with shell code, you don't need to understand every single function that's called. You just have to look for interesting strings that you need to follow up on if you're an analyst. If the goal is to figure out what the script does at a practical level, knowing everything that is involved with shell code is not super helpful. So my eyes kind of glazed over when I see all this, but I am worried about some of the functions. I mean, get module handle and get proc address. I mean, those function calls they're not usually fired off by PowerShell scripts. They're usually fired off by fully built, compiled Windows executables. But here we have it here. Remember, I said before, all it's doing is manipulating memory and stuff like that, it's probably malicious, what we have here. So I'm going to be perfectly honest with you. I don't understand everything this does, but that's the gist of it. We have another randomly named function here, another randomly named variable. This has to do with memory, but other than that, I don't know. Another randomly named variable. Reflection is something you always want to look out for. That's basically kind of like using the PowerShell address space for stuff that it shouldn't be, like fully fledged programs that are usually malicious, like backdoors and stuff, like here, for example. Same thing here, not seeing a lot that I recognize, but no interesting strings as well. We have more randomly named stuff. All of that is just to prepare this to run. Everything I just went through is to prepare this to run, and I don't understand most of it, quite frankly. But what I do understand is this is highly important. This is key to what are we looking at? What is this going to do? If you ever have an encoded buffer like this and you haven't figured out what it is, you probably don't know everything that what you're looking at is capable of in general. So I'm just going to leave that there for now. By the way, we're running a little long, but stay if you can. We have virtual alloc, which is a very low level call in Windows. Very important for malware analysis, like of PE files, but we see it here in a PowerShell script. What virtual alloc does, I can go look it up in MS, but I'm not going to. Well, I'll just tell you what it does. It asks the OS for a block of memory at the size you specify, and it gives you back where that is located. And wherever it's located, plus the size you asked for, is the memory that the OS has allotted you. So the fact that it's here is strange. It's also in pretty much every piece of malware that's ever existed, as well as almost every legitimate Windows program that's ever existed too. So this looks like it just copies this into the space we just asked for from the OS. And this probably just runs it. We have a .invoke here. So the only work we really have to do here is to figure out what this is. Now, do we have any hints as to how it's encoded? We have base 64. That's interesting. So a little tangent here, I guess, but whenever you decode something and it's not completely random, like you see other stuff, for example, you see a URL here. If you look closely, noip.org is a common site for malicious C2 to be hosted. But other than that, we don't really see anything except for this giant string here that's uninterrupted. Notice how there's null bytes and stuff in here. And then there's just a big long string. So one way you can try to guess what this I'm guessing this is shellcode because of that. I see strings, I see control characters by the OS and stuff. I see a lot of gibberish. So I'm guessing this is shellcode. You can disassemble in here, but it's very hit or miss. In this case, it looks like a miss. But we did get this noip.org here. That's a little weird. And I'm just going to try magic here just to see if it works. It may or may not. Nothing of interest could be found. It's been a little while since I looked at this, so let me just check something really quick. There's that big string. I'm just seeing if we can get lucky decoding it. No. So the code itself is going to actually decode what that is, but I'll tell you, it's basically an encoded user agent, a fake one, just because I've looked at the shellcode before. But for this level of analysis, all we're really getting out of it is this tappa.noip.org. Let's see if anybody talks about this on Google. Nothing. Spyware and malware. And it's a Dyn DNS. So you can, whenever you see like this, when you see 16.9K siblings and they all look like this, it means it's a dynamic DNS host. So unfortunately, given what we have, that's the most we're going to learn. We're going to learn that this involves this URL, but it's shellcode that basically connects there, gets whatever it is back and executes it. If you wanted to, you could throw this into a sandbox, or you could emulate it, assuming it's shellcode, but that's out of scope for this. So let's go to the last one here. Actually, let's go back to the presentation quick. Talked about magic feature. It guesses how data can be encoded or compressed. If it involves something like RC4, AES, anything that involves an encryption key, it will never be able to guess it because it's just going to guess encoding and compression methods. So it's not going to help you with anything that involves like an RC4 key or even an XOR key if it's multi-byte. If it's single byte, you might be able to get away with it, but most of the time it won't work. Last one we're going to go over here. It's the most complete example out of all of these, and it's for Cobalt Strike. You will see this from pen testers in your organization or pen testers that are hired by your company, or actual bad guys, ranging from, opportunists to APT or ransomware. It's a very popular attack framework. And that's the last example we have here. I think it says in Metasploit. This is either Metasploit or Cobalt, but I think it's actually Cobalt. But anyway, it doesn't really matter too much for the purposes of this. We just have PowerShell. So this is probably from a PS1 file or something, or arguments to PowerShell.exe. And all we care about is this big blob here. We see hidden window again, which makes us so it won't show up when it executes. Then we have an encoded command. So let's go here. This time I base 64'd it. Let's magic first. And it basically just guessed that it's base 64, which is correct. See, it says from base 64 here. I don't know, it says from base 85, but from base 64, we get this. Oops. So you'll notice that every other character is a null byte. So I usually remove null. and you get this, which is another layer. So this is layer 2, already showing how malicious the script is. We see some of the same things we saw before. gzip stream, read to end. Let's throw this in here. All we want to do first is this from base64 string. We see IEX after, so it's got to be PowerShell. Once again, it is a gzip stream. So we're going to use gunzip. Got to get rid of my null bytes there because that was messing up its ability to decode. And what do you know? We have another layer. Okay, so the style, I can tell the style here is a little bit different than the last one. For one thing, it already appears nicely tabbed, and that's how they had it when they encoded it. So this was probably a different person that made this than the last example. We have an encoded buffer, but we also have this now. We have this is just an XOR loop, which means it will take the key and it will apply it to each byte to transform the data into what it's supposed to be. So let's take this, the base64 string here. We'll go back to the full script, but let's take this here, chuck this into here, and I notice I left something out. Okay, interesting. Oh, yes. So couple things. Let's make sure I have a whole thing in there. Okay. We base64 decoded it and it's gibberish, unfortunately. But there's there's a difference between gibberish and completely random. This is not completely random because there's patterns. This character happens 5 times in a row. This one happens 1,000,000 times in a row. This one happens 1,000,000 times in a row. And that's a telltale sign of XOR encoding. So even if I didn't have the key, I would know that this might be XOR'd. This is probably white space or it's either like if this was a message, a text that's encoded, this could be white space or null bytes if it's like something more machine oriented. But we know the key because remember, we have BXOR 35, we have the loop. What this loop does, just quickly, is it starts at 0, it increments until the size of this is reached using this key. So in order to look at that in CyberChef, all we need to do is do XOR 35. Okay. So I don't know why, but sometimes if you're translating between binary XOR and oh, no, it was bitwise XOR, not binary. Sorry, it was bitwise. That's why I'm using decimal here. And what you have here, obviously, is an entire fake header, really. You have this, which looks like a URI path. Let's chuck this into Google. I don't know if it's going to say something bad about that. No, not really. So maybe that's oh, okay. So yeah, there is an example of this string being used. But it's in the middle of a malware analysis report. But this, I'll tell you, this looks insanely bad, whatever this is. That looks very bad. But it's a URI path in the article, so I can somewhat guess that it's a URI path in this. We have a whole except header, a fake refer, obviously. This fake refer, we're not referred by anybody, right? So that means this can't be right. This is malicious because we didn't come from here. This has nothing to do with this, and it's buried in a big malicious script. So basically what this will do is if you show up in proxy logs, a good network analyst that can look at proxy logs will know it's fake because it'll just appear out of the blue. Like they'll never have connected here. And all of a sudden they're being referred from there. That can be a telltale sign. Maybe it fires on this because it's a known string. We have an entirely fake user agent, Mozilla 5.0. This one's a little bit older that they're faking. But the real user agent is PowerShell. And we have an IP address towards the end. And these PowerShell scripts and shellcode from Cobalt and Metasploit and stuff like that, the C2 is usually at the end. And here it is. Anything on virus total? Chupa is like one of the most malicious ASs on the internet. It's basically like a bulletproof host. A lot of APT uses it. So no bueno there. And we didn't even need to know that this was malicious by looking it up, quite frankly, because it's buried in this script at the end here. So that's that. But let's say you're having trouble decoding. Oh, wait, before we keep going here, does anybody have any questions? Okay, we're way over. So I'm going to speed up here real quick. All of this looks pretty much boring to me. There's another B XOR in there. I'm not sure what that is. I'm guessing that comes from the back door and it's XORed or something. Maybe it gets this from the destination. I'm not sure, but it starts it as a job, whatever that means. In order to know what that means, you would have to look it up in MS documentation. Let's say you can't decode it though, for whatever reason. Well, I'm just going to take one of these examples and show you a sandbox really quick. Let's try this one. So, I'm going to use any.run for this, which is a free sandbox. But it shows what you put on there on the internet. So be careful. Make sure you're not putting proprietary stuff in there, or anything that might tip off an attack. Like if you're actually dealing with a real attacker, you're not going to want to upload this to the internet. You're going to want to either pay any.run to use their private stuff or set up one internally. There's tons of different options. But what I'm going to do, kind of trick you can use to get this to work for free, is to put a big command into a file and let it run. I only recommend doing this on non-Windows system, but I'm going to show you how it works. I'm going to name this test2.bat. So hopefully this runs as a batch file. If not, I'll just show you the example from another example, but I put it in there, test2.bat. I'm going to run. You can fake connections to the internet. If you click fake net, what it'll do is it won't connect out to the internet. It'll just, there will be a fake web server there that responds with a generic text file, which can be kind of useful if you don't, let's say you think an attacker is looking at their C2 server really closely and you don't want to let them know that you're connecting or analyzing them. You can use fake net. You can also route it via Tor so they don't know where you're coming from, but it's going to appear to come from any.run or their VPN provider anyway. So I'm going to run this. I put in test2.bat. Hopefully this runs. What you see here is what's happening to the sample. It's going to show a process tree. It's also going to tell us whether it thinks it's malicious or not. It's going to show us requests. This is the dynamic analysis I was talking about before. So we knew this part. It tries connecting to Chupa with PowerShell, not Mozilla, like it said, it's PowerShell. And it's hosted in Sweden. It's going to go out there. Now the C2 is down now, so it's never going to get an answer and it's never going to continue. But we can safely assume there was oh, well, maybe it's up, but it's not going to respond with backdoor, I'm pretty sure. If it did, we would see more here, but it probably just responded with a dud. I'm going to stop the analysis and let's see what it tells us. Suspicious activity. We see our big command there. We see the connection to Chupa. You can also view this as a text report, which is very useful. And this is what's going to get archived online. It shows a process tree. Since I just threw it into a batch file, it's going to appear as command.exe with a child of PowerShell. That's normal to me. But the not normal part is where it goes out to Chupa. That's pretty much always bad. There's no businesses really using that. No real businesses using that. It's basically a bulletproof host. So no real interesting stuff after that, but this is enough to know it's bad. And if you remember, we know mostly what this does by looking at it. It goes out with that fake information. I wonder if we can see the fake information. Well, anyway, this is enough to tell me it's bad at the very least, because PowerShell shouldn't be connecting out to Chupa ever. You can make a rule for that in Anvilogic now, and it'll always be bad. Anyway, I think I'm going to stop here right at the top of the hour, and I'm going to hand it back over just for some quick administrative stuff.
Thanks, Kevin, and thanks everybody that joined today. It's been awesome to have you guys. If you have feedback, if you have any questions in the last few minutes, feel free to drop it in chat and we can bring it up. We can run over for a few if we need to. But putting in a little bit of a plug for our next session. These are bi-weekly, so if you've registered and you added the invite, it should be on your calendar every 2 weeks. If you have the time and you'd like to join in the topics of interest, feel free to hop into our sessions. Our next one in 2 weeks is going to be with Rakuten Mobile, with Soda Aoki and Rohit from Anvilogic. It's going to be about defending against MFA attacks, techniques and stuff. So it's going to be a really awesome session. If you visit anvilogic.com/workshop, you'll see the next session. But if you're registered for this, you already have the invite. It's the same link every single time. So you don't have to re-register or anything. You can just hop into the same Zoom. I'll be following up with all of you guys with the giveaway code. We usually do some sort of giveaway detections or something that you guys can use to play around with kind of and to test your skills after these sessions. But if nobody has any other questions, thank you so much for joining. Thank you, Kevin, for this awesome hands-on experience. We really appreciate all of you guys coming. Thanks, everybody. Bye.